Good evening, and thanks for joining tonight's TI Technology webinar hosted by Texas Instruments. Tonight we're going to take a look at how TI Technology can support the teaching of two-way tables and chi-square distributions. My name is Mike Houston, and I'm the moderator for this event. I teach algebra and calculus near Pittsburgh, where I use TI Technology to make tough-to-teach, tough-to-learn concepts accessible to all my students. I'm really excited to be joined by our two panelists tonight, Ray Barton and Landy Godbold. Ray has been a T-Cube national instructor for many years, and he teaches calculus and statistics, and has also helped develop many T-Cube workshops. He's leading a webinar for us tonight. Ray is part of a joint effort by Texas Instruments and NASA to develop classroom materials that incorporate actual data and problem situations from manned space exploration. He enjoys using graphing technology to make mathematics accessible and interesting for students. Ray, thanks so much for joining us tonight.
Thank you. Good evening.
And Landy holds degrees in applied mathematics from Georgia Tech and retired after a mere 40 years of teaching. He introduced statistics as an elective course early in his tenure there and has actively promoted the teaching of statistics since his participation in the Woodrow Wilson Summer Mathematics Institute in 1984. A recipient of the Presidential and Tandy Awards for Teaching and former chair of the ASA NCTM Joint Committee, Landy continues to look for new ways to use technology to help students understand subtle statistical concepts. Landy, we're excited to have you with us tonight.
I'm happy to be here. Looking forward to a great evening.
We're expecting a large crowd, so your audio is muted. If you have any questions throughout the webinar, please feel free to get those asked. Ray and Landy are great at answering questions. Feel free to do that using the Q&A window on the right side of your screen. We'll also be using the chat window to send general messages. As a reminder, this is being recorded, and we'll provide a link to the recording in a couple days after the webinar, which is really the best way to follow along. That way you can pause or rewind and go at your own pace. So if you have a handheld or software that you're going to try and use tonight, the best bet is just kind of sit back, ask questions if you have them, and interact with what we're going to be doing tonight. We'll also be providing a link for the event certificate of attendance, as well as the documents at the conclusion of the webinar tonight. We hope you don't have any audio issues, but in the event that you do, find your name in the participant window. In that same window, you should be able to find an icon that looks like a telephone. By clicking that icon, you'll receive call-in information, which should be able to transfer you from the audio broadcast, which is the default, to using a landline or a cell phone. Ray, you have control. Feel free to share your screen.
Uh-oh. It says Cisco WebEx service is not responding.
Okay, so that's not what we're looking for.
Okay, I'm trying it again. Now I'm hoping that you can see my screen.
Yep, it looks good, Ray.
All right, let's see if my heart rate goes back down to normal in a minute here. So tonight we have several webinar goals. Some are conceptual and some involve the technology. Some of the concepts that we'd like to develop are the idea that probability is a proportion, that conditional probability is a probability on a subset, that independence is a whether or not decision, and that good graphs convey information clearly. And then on the computational side, sort of the technology side, we're going to show some ideas about using spreadsheet features to find probabilities. We'll use spreadsheet features of the TI-Nspire to find conditional probabilities. We'll build and interpret comparative bar charts from a summary table. All of this will be on TI-Nspire since TI-84 doesn't really have these spreadsheet features that we'll be using on, the TI-84 doesn't have the spreadsheet features that we'll be using on Nspire. We'll also interpret some comparative segmented bar charts and we'll show how to implement chi-squared tests for independence and possibly talk about homogeneity and goodness of fit. And we'll do that on both the TI-Nspire and on the TI-84, the chi-squared tests. Landy, anything that you wanted to add to those webinar goals?
Yeah, so that people don't panic if they don't have an Nspire. One of the reasons for using the spreadsheet features on the Nspire is that it makes much more clear what computations are being done, especially when you're looking at conditional probabilities. So even if you don't have the Nspire to use in your classroom, if you use it, understand what Ray does tonight with them, then I think it'll help teach the concept when you get your students in front of you and need to do the actual computations.
Great. So since we are doing some spreadsheet style, sort of Excel or Nspire spreadsheet style computations, Landy and I were wondering about what your experience is. So we are going to send you a quick poll, and if you could answer that. Here's the question and the choices. Hopefully you're seeing on your screen. Do you have experience writing cell reference formulas, using cell references and the $ to lock in a row or a column or both? So if you could tell us a little bit about your experience, just respond. I think the quick poll that you see that popped up has A, B, and C. So A is no experience, B is little experience, just a little, and C is lots of experience. And that's, again, experience using cell referenced formulas in a spreadsheet. So if you could respond with one of those three choices, that will give us a little better idea of possible adaptations that we might need to make tonight.
And Ray, one thing I just want to add while we're getting some responses, if you're viewing the webinar on a mobile device, you probably don't have access to some of the WebEx features that those that are joining us on a computer or a laptop might have, such as the poll features. So just wanted to add that in there. So we're closing the poll. It'll close in about 15 seconds, and I'll share those responses once we have them.
Great. We're going to be using cell referenced formulas in the context of several AP test questions, old AP test questions. And the first AP test question we'll be looking at is from 2011, and it's number 2. It involves some conditional probabilities and some questions about independence. And so that's why we're wondering about your background with cell reference formulas.
So Landy and Ray, I'm not sure if you had the results, but we had 14% respond with no experience, choice A, 29% responded with B, and 22 with C, and then we had about 35% that did not have a chance to answer. So 14%, 29%, and 22% respectively.
Okay. All right. So pretty even spread there. So let's move ahead to that first question then. And keep this idea in mind as we look at this first AP test question, the idea of independence in a probability setting.
And there's a different setting.
So Landy, yeah, Landy, why don't you go ahead and take it a bit from here, and I'll jump in if there's a question or a comment that I think I might need.
Okay. So this is the 2011 question number 2. And just as an aside, 2011 I think was one of my favorite exams of all times. All of the questions on that year's exam were really good. So this one leads to a question about independence, but initially you're given this kind of table. These are the data from the table, 500 voters in the township, and the breakdown by party registration is shown in the table. Someone just commented they were having trouble hearing me. Is that any better?
It sounds louder for me, Landy.
Okay, I bumped it up just a little bit. Thanks for the request. So this is number 2, and it asks some questions along the way. But before we actually look at the questions that were asked, we want to look at a question that was not asked. And that is just to take a real quick look at the table and say, okay, what's the probability that a randomly selected registered voter in Franklin Township is registered for Party Y? So just a straight out direct probability calculation. And in doing this on the Nspire, we'll get to see some of those spreadsheet calculations we were talking about. So notice the formula we're going to be using. A probability, as we said at the beginning, is a proportion of something. In this case, it's the proportion of everything. So we're looking for how many Party Y people are there in the whole population. So that's an easy calculation to do. It's 168 over 500 that we can read off the table. But now we're going to take a look at how we build these kind of calculations into the Nspire as a spreadsheet. So Ray's going to open up a list and spreadsheets page in a new document and fill in the raw data from the table that was given to us in the problem. Ray, do you need me to read those out, or do you have them in front of you?
I've got them in front, but just keep an eye and see if I get them right. Okay. You might want to comment on why we're leaving the male and female blank for a minute and why we're doing decimal.
Yeah. So notice that he's entering the data with decimal values instead of just typing in 60, type in 60 decimal. The reason for that is that the default for the Nspire in doing calculations is to do exact fractions when you do division. So we don't want to end up with an answer of like 168 over 500 as a fraction. We'd rather have decimal results when we do our probability calculations. The other thing he commented on is we're leaving the labels for male and female off for the time being. And that's in order to enable us to look at a particular kind of graph of the situation in a few minutes. That and then we'll take the population off and put in the male and female to look at some other things. But it's a way of getting the calculator to show what we want to show in a graphical display. So he's going to put a formula. Ray, do you want to explain the formula you're using?
No, go ahead. I was just going to say, so I've got the table entries, and now we'll do the column totals with the formula. So
okay. Actually, do you want yeah, so he's going to put in the column totals. And here he's just going to use a sum formula. That's S-U-M, not S-O-M-E.
Or we could just type in sum, which I'll probably do after the next time around. So sum of B1
through B2.
Through B2.
So the colon tells it to run that. If you notice the formula in the lower left-hand corner, you can see what he's typed in if you forget what you put into a cell.
And then we're just going to copy this. We can copy an entry. Notice that Control-C is the shortcut there, and I'll just be using that most of the time tonight. So we copy an entry. Then I'll go over, and if I hold down the Shift key and drag to highlight the region I want to copy to, then I can go back to my, I went to hit the document key, went back to the edit menu, and then we should be able to paste. And notice the shortcut for that is Control-V, just like most other software applications. And so that gives us the column totals.
Yeah. And it adjusted the formula as he moved from column B to column C and D. The formula changed. Remember, he copied something that said the sum of B1 and B2, and when you look at the other formulas, they became C's and D's. That's part of that cell reference thing that we were talking about earlier.
Okay. So next, do we want to do the bar graph, Landy?
Yeah. So in order to visualize what's going on, we want to take a peek at just how these proportions are distributed across the population.
So I went back to the menu, and I'm going to insert a second page in this document. And that's the beauty of an Nspire document, is you can have multiple apps or multiple pages that interact with each other. So we'll insert a data and statistics page, which is used to make statistical graphs. And then I need to select the variable on the x-axis, which would be gender. And then we need to add the y variable, so I click on Menu and then Plot Properties. And then I don't want to add a y variable. My students will try that all the time, and then it thinks we're making a scatter plot. Instead, I want to add a y summary list, so that's the option that's highlighted now. And then we can choose party W as one of our variables, and then I'll just go through that same menu process again. Menu, Plot Properties, and add another y summary list, and choose party X, and then one more time, and add party Y. And then, as Landy was saying, if we hover the mouse over these different bars, then we get the numbers that correspond to them. So we can see that the green bar represents 168 people that are members of Party Y out of a total of 500.
And it shows
so about 33%.
Yeah.
Okay, and then so now do we want to go back and do the row totals? So let me, so let's go over here into column E, and excuse me, we'll enter another command. So I can just type, we always, just like in an Excel spreadsheet, start cell commands with an equal sign. And then I'd like to take the sum of B1 through D1. And then I'll copy that. So I'm just highlighting it and pressing Control C to copy it, and then go down, hold the Shift key and drag down. Then I can do Control V, and that should paste it. Let's try that again. There we go.
Okay, so at this point, the table that we're looking at on the Nspire is the one that was given to us in the original problem. So right now, what we're looking at is what we're given. So the calculations that Ray was doing was primarily to introduce you to the sums idea on the spreadsheet. It hasn't made any progress with us in solving the problem yet. We said we wanted to get the probability of being in party Y. That was our pre-question. We got that from the graph already. We saw it was about 33%. So now Ray's going to do that calculation for us in the table by doing the actual division. So what we need to do, again, is to take the number in the particular party and divide it by the total. So those numbers are all in the table already, so you can just refer to where those numbers live in the spreadsheet in order to do the calculations. Notice that he had to, in order to name the columns here, he had to use a different name than what he used earlier. Earlier they were called party W, party X, W, party Y. He can't reuse those names because those are variable names to the device. So something related but not identical for the new labels.
So now we'll do those. Notice I've left a couple of rows because right now we're doing the party probabilities, sort of the like column totals, and we're leaving space to come back and do the conditional probabilities in a minute. So in this cell, I'm going to enter the command. I want to take B3. That's where our total was, and divide that by dollar sign. And the dollar sign, so this is that cell referencing we're talking about, is over here when I click this key, and it brings up some special symbols. Dollar sign and then an E3. And Landy, do you want to talk about that purpose of that dollar sign?
Sure. If you remember when he copied the formula initially that was in B3, which was the total for party W, he copied that over to column C and D, and it automatically adjusted the formula. So instead of saying B, it changed itself to being column C and column D. Well, now the divisor here is that 500 in column E, And as we calculate the probabilities for being in party W or X or Y, we want to divide by 500 every time. That 500 is not going to change. So the divisor is column E, not changing, but the numerator is column B, column C, column D, depending on which party we're with. So the denominator here, he wants that dollar sign, which in a sense locks the the column to which it's referring.
And now I'll copy it into the other two columns. So Control C to copy it. And we'll go over, hold down Shift and drag, and then Control V to paste.
And Ray, if you'll click on each of those cells successively, so we can look at the formulas in them.
Yep.
So notice the B in the numerator changed to a C and a D in the other columns, but the E is still an E. And there's that 33% we saw on the graph. So that's the answer to the pre-question. So let's actually do the real question now, the AP problem.
You want to jump back over to the PowerPoint?
Yeah, let's take a look and see what the question was. So this is what they actually ask as part A of the original AP question, is given that the selected registered voter is male, what's the probability he's registered for Y? Now note, remember what we just calculated was the probability of being registered in party Y among everybody. So this is a conditional probability, and the key for probabilities is it's a proportion, and the key is of what, of whom, of what set. So what's the denominator as much as anything else? So previously our denominator was everybody. Now the denominator is going to be just the number of males. So let's take a peek how we can get that in the Nspire document. And the cool thing here is that he's already done all the work for it. It's the same division that we did for the totals, except instead of using totals, we use the respective entries in the male-female rows of the table rather than the total table. So he can use the same formula that's on the bottom row and put it in the upper cells, and it'll give us the conditional probabilities.
So I just did, sorry, go ahead.
Yeah. So these are conditioned on the gender. That is, so it's among the males, among the females. That's what will be the probability that we'll see.
So let's see if this works. I think I should be able to just copy this formula in cell G3. So I just did Control C, and I should be able to just paste it into the rest of my table here. So let's see if Control V will do that for me.
Aha. Got the answers we were expecting. That's a good sign.
Always.
So to interpret these, let's think about what we're looking at. The one we're actually after, remember, is the probability that among the males, the person is registered in party Y. So what the cell that Ray has highlighted right now, the 0.24, is that calculation. D2 is the number of males who were registered in party Y, which is 48, divided by the total number of males, which is the 200. So the calculation that's being done there is the Y's among the males divided by the total number of males. So that's the computational answer to part A. Part B asks a question about independence. In a sense, most of the effort tonight is thinking about the idea of independence. And so here it asks, is the event male and is registered for party Y? Are those two events independent? And then we have to justify that based on the table. So what's the definition of independence? The full definition is that the conditional probability of being registered in party Y, given that you're male, is the same as the probability for being registered in Party Y among everybody. So this is the whether or not kind of thing that I mentioned earlier. So whether or not you know that the person is male, does it affect your understanding of their chance of being from Party Y? So Ray, can we go back to the table on the Nspire? So if those two events were independent, then the number that Ray has highlighted right now, the 0.24, would be identical to the number right below it. Because the number that's now highlighted is the probability of being a member of Party Y among everybody. And the one above it is the probability of being a member of Party Y if you're male. If those two numbers are equal, then the two events are independent. If those two numbers are not equal, the two events are not independent. So in this case, the answer to part B is no, they're not independent. Boy, wouldn't it be nice if we could see that in a bar graph?
So Landy mentioned earlier that there was a reason why we were holding out the female and male titles. So now we're going to put those back in. I think it's female first, was how it showed up in the original table, and then male. And we're going to take out the total population label. And now we'll jump back over and see how our bar graph has changed.
So total is not visible now, but male and female breakdown are. Which is sort of good and sort of bad.
Yeah.
But this doesn't allow us to make the comparison we were able to make in the table. So I can't compare that 24% to the 33% that's in the definition. But the good news is, since there's only two possibilities, two groups, males and females, if the male percentage, that is the percentage of Party Y among the males, had been the same as the percentage of Party Y among everybody, then the percentage of Y among the females would be the same as well. In other words, I can't have two of those three equal without the third one being equal. So I can't compare.
So that's the two green bars.
Yeah, so the green bars, it's not the direct comparison that the definition asks us to use, but this is good enough. That is, if these two numbers here, the 24% in the right-hand green bar and the 40% in the left-hand green bar, if those had been equal, then when we looked at the table, the total in the Party Y column would have been the same as well. All three of those numbers would have to be the same. One thing that's worth mentioning here, Ray, do we have time to look at reverse conditionals, or should we skip over that?
No, I think we've definitely have time, so okay. Let's go ahead.
Okay. One of the things that students have trouble with conditional probabilities is conditioned on what? So what we just did was the probability of being in Party Y given that you're male or given that you're female. That's what's shown in the table that he constructed there. So if you look at there's a conditional probability. Each of those is given, the top row is probability of being in a particular party given that you're female, and corresponding row, second row, is given that you're male. That's not the same thing as the probability of being male given that you are registered in Party Y, or the probability of being female given that you're registered in Party W. So those require the reverse division. In the one that we were just looking at, he divided by row totals. He had to divide by the total number of males or the total number of females. In order to get the what I call the reverse conditionals, that is conditioned on party, then we still need to do a division and divide by total, but this time instead of dividing by the total number of females or total number of males, we need to divide by the total number registered in Party W or X or Y. And what's fun to do is then compare sort of corresponding entries in the two kinds of tables.
So now I will just again use the copy and paste features to speed things up. So I'm about to compute the first conditional probability. So I've got B1 divided by $3. So now the dollar sign is switched to lock in the row, because we want to do, the row totals are in row 3. So we want to preserve those. So that's that first probability, conditional probability. And we ought to be able to copy that into the rest of the table. So if I highlight it, again, Control-C, and then highlight where we want to copy it, and Control-V, we should get these other conditional probabilities that Landy was talking about.
Okay, so there we go. So let's just take one particular number there. If you look at the top left entry in that particular display, that 68% is saying that among the members of Party W, 68% of them are female. If you look at the corresponding entry in the earlier conditional table, can you get to that one easily, Ray? So the top left here is saying of the females that are registered, 20% of them are in Party W. So 20% of females are in Party W, but 68% of Party W is females. And that's hard for kids to wrap their heads around. They sound so much alike, but they're vastly different. In this, you see in this case, the numbers are hugely different.
Do we want to take a minute and talk about how what we'd have to do to make bar graphs for this new set of conditionals?
Yeah, I think that'd be worth walking through, yeah.
So I think the easiest way to do this, and maybe the only way to do it, is to create a new problem. Because we need a new variable called party, with party W, party X, and party Y as elements in that column. And so we've already got this one built in order to save a little time, because there's nothing new here that we haven't already showed you. So here I've added a new problem. Notice the tabs say 1.1, 1.2. That's where we had the old table and the old graph. And now I have a new problem, 2.1. And this is the new variable I was talking about, a new variable called party. And it has elements called party W, party X, and party Y. And we still have the same information about males and females, but I guess would that be the transpose of the other table? And that allows us to make bar graphs where party is the variable on the horizontal, and then male and female are our summary Y variables. And again, if we mouse over them, we can see let's see, this is the 68% I think that Landy was talking about. And then the 31% of, so male and female in party W, male and female in party X, and male and female in party Y. But again, if you're going to do that transpose and you'd like to get the bar graphs going the other direction, probably the best way to do that is to create, I think you'll need to create a new problem and build the transpose matrix and the new variables, the new label variables.
Okay, dokie. Let's go back to question B for just a minute. And maybe the bar graphs that you showed us initially for
okay.
The 1.2. I think that's
right.
where the bar graphs are, aren't they?
Right.
Yeah. So remember the complaint I had a minute ago was that I really want to be able to see kind of the percentages of, well, I want to see the conditional probabilities. These are counts here. I can see the conditional probabilities by mousing over. So I can look at the numbers and see there's a 40% there and go over to the corresponding bar in the other part and get 24%. But remember, the number of males in this problem is 200. The number of females in this problem is 300. So the total, even if the percentages were exactly the same, the bars would not look the same. And so that bothers me a little bit. So there's another kind of graph that we want to just mention to you. Unfortunately, the technology will not produce it for us yet. There is a request in. We hope that it was coming down the road somewhere. But there is another kind of graph that actually appeared in the problem statement as well. And there it is. It's called a segmented bar graph. And notice it's on a proportion scale. So it goes 0 to 1. So it's adjusted for the fact that you have unequal counts of males and females. And now the question about is party Y independent of male, I can look at the party Y segments in the two graphs and say, hey, are those the same length? They're not. So the answer is no. And if you'll notice, the length of the top bar is 40%. It goes from 0.6 to 1. And the length of the bottom bar is about 0.24. It goes from 0.76 up to 1. So this visual does the comparison with your eyeballs without having to do any computations at all, if you can get that kind of graph. Ray, you want to show the next slide on that as well? The advantage of this particular version, notice we've added an extra bar for total. Again, the definition of independence is I'm supposed to compare the conditional Y given male to the Y from the total. So I really want to be comparing the bottom two bars in this graph rather than male and female bars. But conveniently, if you have only two cases, that is males and females, two classifications, then I can compare the male to female Y bars and still come to the same conclusions. One other thing I want to mention here, and this is not a question, well, I think it is too. Look at question C, right? So this is the last part of this question. They give the bar, the graph that we just showed, and ask you to complete the graph below if the party distribution was independent of the gender for that township. Okay, so there's a subtle change here that I want to be sure everybody catches. Previously, they asked about, is party Y, that is, I'm a member of party Y, independent of I'm male? Those are events and refer only to one category in each of the two variables. So male on the gender side and party Y on the party side. Now they're asking, are the variables themselves independent? So that is all of the parties and all the genders. Those are different questions. One way to see that is to think about the graph that was given to us in Part C. If party Y, being member party Y, is independent of being male, then it would be true that the two segments for party Y would be the same length. But you can imagine those two party Y segments being exactly the same length, but the party X's not being the same length on the same bars. So it's possible to have the events, male and party Y, are independent, but the variables, gender and party, are not independent. So the question in Part C is not just, is the party Y bars the same length, but are all of the bars the same length, all the segments the same length? So once you understand the question in that way, then the answer really becomes, I don't want to say trivial, but really easy, because all we have to do is go back to the totals that were in our original set of probabilities, the very first things that Ray calculated. That row 3 of that first table that we made, those are the proportions for party X, for party W, X, and Y for the total. Those have to be the demarcations on this new graph that we're drawing. So plop them in, you're done. So our answer to Part C in terms of how to draw it is really row 3 of the very first table of probabilities that we did. So that all of this now has been in the context of we're working in a probability world. That is, this problem, we had 500 voters. These were all the registered voters in that township. No sampling was done. We have everybody. So we have to have exact equality in order to be able to say, yes, we have independence. Ray, let's talk about a different kind of problem.
Okay, so now we're going to look at the idea of independence in a statistical setting rather than the probability setting with the entire population that Landy just described. And we're going to be doing a chi-square test for independence in order to evaluate that idea. And a couple of things to look for in a test for independence. First of all, there should only be one sample that has been drawn from one population. And the row and column totals are variable, so they're not known in advance. And so there's a great problem to illustrate this. We decided to look at AP 2017, AP number 5. And so keep those key points in mind about one sample being drawn from one population and not knowing whether or not, not knowing what the row and column entries might be. So in this problem, we've got a table representing the age at diagnosis of a sample. Notice a sample, not a population, but a random sample of 207 men and women currently being treated for schizophrenia. And then the question that was asked is, do the data provide convincing statistical evidence of an association between age group and gender in the diagnosis of schizophrenia?
Presumably for the population.
Right, right. So, so what we thought we might look at first is a tabular approach, and I've already got the table built again to save us a little bit of time, but there aren't any technology skills we haven't already talked about. So here's that same table built into an Nspire document, and to make things simpler, instead of 20s, I said 2. So this column represents the people diagnosed in their 20s. Column C is people diagnosed in their 30s, then 40s, and 50s. And here we just have the raw counts of men and women along with the totals, the column totals. But what we really need are those same conditional probabilities that Landy described before when we were trying to check for independence between gender and party affiliation. So I've gone over here and built a corresponding table with proportions. And it's the same basic idea with the cell references and totals. And so what we have here, this 0.07 would be the, see, notice that's in, I labeled this V for 5. So this is people in their 50s. So this would be about 7% of people were diagnosed with schizophrenia in their 50s, whereas this one is a conditional probability. I think that would be the probability of being diagnosed in your 50s if you're female. I believe the second row is female. And then the top one here would be the probability of being diagnosed in your 50s if you're male. And so we might ask that same question, is age and gender, age of diagnosis and gender, are they independent events? And if we use the same approach as the last problem, then we'd have to say, well, this is the probability, this one that I've got highlighted is the probability of being diagnosed in your 50s, and this one is a conditional probability for male, or rather 50s given that you're female, and they're not the same. And so we might conclude if this were a population that they're not independent, but this is a sample. And so it's a different approach we need to think about because there's always variability in random samples. So now the question should be maybe a little more fuzzy, not are these two equal or are the other conditional probabilities equal, but rather are they close enough? And they seem, I don't know, do they seem kind of close to you, 7%, 3%, 10%? And as you look at some of these other conditional probabilities in the columns, they seem, I guess, sort of tolerably close, but is it close enough? or maybe they're so far apart that this is convincing evidence for independence.
So
the other thing
here, so the key idea here is that now we have to worry about a sampling distribution rather than just the raw data. Right? So in the background, you know, what are the things that could happen if the null hypothesis is true? If they really are independent, how much wiggle could there be? And so that's what the test is going to check for us.
And then just before we jump to the chi-squared test, we also did some bar graphs for men and women, and then the 4 different colors for the 4 different age groups. And so if you just look at 2 sets of bar graphs and they're color-coded, do they seem similar, or are they enough different that we think something's going on? So now we're going to go ahead and do a chi-squared analysis here. And in order to do that, you have to do a couple of things. First, I think I'll create a new problem. So let me insert brand new problem, and we're going to do our chi-squared analysis. So I'll just do it on a calculator page. And first thing we need to do is store that table of values in a matrix. And so I'll press menu and then go down to the matrix editor. So I need to create a new matrix. And I believe it was a 2 by 4.
2 by 4, yeah.
There were 2 rows. And then the matrix editor pops up, and let's see, I think the entries were 46. Oh, don't press enter. Got to keep telling myself that. I'll use the tab key to go back and forth. Enter thinks that the whole matrix is done. So that's the entries, I believe, for the males, and then the females in the different age groups. And then we want to store this matrix. So I'll press Control and then Store. It's above this variable key, and it gives me this store arrow. Works the same way as on an 84. And I'm going to call it AD for Age at Diagnosis. And now that we've got that matrix entered, then we're ready to go ahead and do a chi-squared analysis. So that's menu, and then in statistics, and then I want to do a statistical test, and there's this chi-squared 2-way test is the one we want. And I have to tell it where the observed matrix is, and that's the one we just created. So I'll tell it it's in matrix AD, and then there's the chi-squared statistic and the associated p-value and degrees of freedom. So what do you think, Landy?
I think I'd reject a no.
Yeah.
They're not independent.
Yeah, pretty small p-value there. And then let me just show you how to do that on an 84. So again, we still need to store that table of observed values. And so I'll go to the matrix editor here, and we'll edit matrix A. So see, again, it's still a 2 by 4. And then put in the values. So 46, 40, 21, and 12 for the males. 53, 23, 9, and 3 for the females. And then I'll go back to the home screen, and now I'll go to the Stat menu and arrow across to Tests, and then scroll down to chi-squared test. And we tell it where the observed matrix is. That's in A. And then the expected matrix will be stored in B. And the test is going to calculate those for me. And then we'll just go ahead and calculate the values. And again, we get the same chi-squared statistic and p-value that we did before.
It came out the same way.
I'm breathing easier. And now just one more thing I wanted to show you here is that you can, let's run that test again, but we can visualize the results. This is a nice feature on the 84. So I'm still going to choose the same chi-squared test. But now instead of calculate, I'll choose draw. And then we'll see that nice chi-squared curve and hopefully a shade, yeah, there it is, the shaded in p-value over here, just this little spot here. So again, a p-value of 0.01. So that's how we would do it on the TI-84. So maybe just in our last few minutes here, we won't have time, I think, to actually do a chi-squared test for homogeneity or goodness of fit, but let's talk about a few key points and how you do that on the calculator, although I don't believe we'll have time to show it.
Well, and also how to recognize when to do each one.
When to do it, which I think is probably the most important skill we need to know right now as teachers. So a test for homogeneity looks an awfully lot when you do it on the calculator. As a matter of fact, it looks identical to a test for independence. But Landy, do you want to talk about what are kind of some of the key features to look for here, and then we'll jump to goodness of fit?
Sure. First of all, both the homogeneity test and independence have data tables that have rows and columns that are counts from the raw data. The goodness of fit test, we'll talk about in a second, does not have that feature. So we have at least 2 rows, at least 2 columns. And we saw in the independence test that the row totals and the column totals could vary because you only have 1 sample. Here, for the homogeneity test, the table looks the same, but before you start, you already know the row totals or the column totals, one or the other, and the other one is left free to vary. So it's really the situation where we have several samples from several populations in the homogeneity test, whereas in the independence test, you have 1 sample from 1 population. So knowing how many groups you took from or how many groups you took really is a key, but also thinking about which numbers can wiggle in the total columns or the total row, that makes a big difference.
So here was an example that 2016, I think, AP response number 2, where so we've got a 2-way table again, but you could really, and there was some kids were offered a choice between 2 snacks, and they were given different types of ads. And so we could think of A, B, and C. Would this be right, Landy, as sort of 3 separate samples drawn from different populations?
Yeah. And sample may not be the right thing to use here because this really is an experiment more than a sampling situation. But you notice that row A, row B, row C, those are fixed totals of 25 because 25 kids were assigned to each of those groups. So those 25, the row totals can't change, whereas the column totals can change dramatically.
Great. And then maybe in our last 2 minutes here, we can just talk about goodness of fit.
So the goodness of fit, your data table only has 1 row or 1 column, depending on which way you want to orient it. But it only has 1 variable in it, and you're comparing it not to some other columns or other rows, but you're comparing it to a set of constant values that are specified in advance by something you think you know about the situation. So the example we have for that one is the moose problem from a few years ago. Was that 2008, right? Is that right?
Uh-huh.
So there, the data is in the right-hand column, the number of moose. The fixed proportions, or the acreages, those are what we're really comparing to. So you only have 1 column of data in a goodness of fit situation, whereas you have multiple columns and multiple rows in both the homogeneity and the independence.
And then since the expected matrix is already predetermined, the proportion of total acreage, then you would need, on the calculator, you would need to enter 2 different matrices, one for the observed, and you would enter the expected matrix. They'd both be single column matrices, but that's why it's a different test. So when you go to the test menu, then chi-squared goodness of fit would be a different test, and you would have to have already entered both of those matrices before you could run that test. Anything else, Landy, before we give it back to Mike?
I think we didn't leave him enough time as it is.
Okay.
I tried to watch questions, and I hope we got the questions answered that needed to be answered.
And I noticed some of the ones we didn't, some of our other participants were great to jump in and help answer questions. All right, back to you, Mike.
Thanks so much, guys, for everything you shared. Speaking of questions, if there are any last-minute questions in the last couple minutes here, feel free to try and get those asked. I know Landy and Ray will try and get those questions answered. When you leave the webinar tonight, a brief survey will automatically appear in your browser. Your feedback helps us plan future online events. We really listen to your feedback, and we hope you share your thoughts. To receive a certificate of attendance, go ahead and click the link in the chat window. Also listed is a link for the documents that were used tonight by Ray and Landy. If for some reason you missed these links or they're not working for you tonight, just hang tight. You'll automatically again get a follow-up email in a couple days. And that follow-up email will be a link to the recording, a link to the documents, and a link to the certificate as well. If you're watching this on demand, go ahead and copy that link into your favorite browser to receive your certificate. Whenever the webinar ends tonight, if you still have follow-up questions that might not have been either answered tonight or they come to you after the webinar ends, feel free to give us a call at 1-800-TI-CARES or send us an email at ti-cares@ti.com. We'd love to hear from you. Thanks so much, Ray and Landy, for everything you guys shared tonight. We really appreciate it.
Thank you, everybody, for attending. I hope it was you got something out of it.
Yes, thank you, and thanks for your help, Mike.
Thanks so much, guys, and we hope to see everyone back online next week. Have a great night.
Okay. Good night.